Hey, hey, hey. Unit 4, Lesson 3. All right. Rules of exponents. A lot of this should be review. So let's just get started right into it. Let's first go over the rules of exponents, okay? And some examples here. Now, I'm going to go over this, kind of quickly because this should be known. This is Algebra 1 stuff. All right? Now, anything to the power of 1 is itself. Okay, 5 to the power of 1 is 5. Good, simple. Anything to the power of 0 is not 0, it's 1. So if I have 5 to the 0, that's 1. If I have 10 to the 0, it's 1. If I have 13 million to the power of 0, it's 1. All right? Now, rule number 3. If I have anything with a negative exponent, okay, I can make a fraction out of anything by putting it over 1. In order to make that exponent positive, I take that term that has a negative exponent and I flip it. I bring it down. So here you go. X to the negative 1 is equal to 1 over x to the positive 1. Okay, and here's our example. I'm going to give you another example here. If I have 3x to the negative 2 over 4, okay, the only thing that my negative exponent is connected to is the x, not the 3. So this is the only thing that I'm flipping. I would have 3 over 4x to the positive 2. All right. Now, 4, 5, 6, let me see here, 7, 8, okay, 9 is sort of repetitive for what we just did. Anyways, these next few are just algebra. So you see, if I'm multiplying two common bases and they have exponents, I add the exponents. Okay, that's number 4. So I have x to the 2 times x to the 3. I add the exponents, and it becomes x to the 5. Simple. If I'm dividing, okay, let's take a look at number 5 here. If I'm dividing two things with common bases, then I subtract the exponents. Now, keep in mind, in subtraction, orders matter. So it's top minus bottom, okay? So if I got a situation like this right here, it's 3 minus 2, not 2 minus 3. Now, common sense would tell me that if I had x cubed over x squared, I can just reduce, meaning I take these two x's out, and I take 2 from here, and I end up with a 1. Okay, so it's just x to the 1. All right? But you get that by subtracting. All right, number 6. If I have an exponent that is raised to another exponent, I multiply them. Meaning, if I have x cubed and that whole thing is squared, I just multiply the exponents and I get x to the 6th. All right. Now, 7 and 8, I stress a lot in class. If I have a couple of terms that are all raised to one exponent, that exponent applies to everything. Okay? Everything in the parentheses. Meaning, let's look over here. If I have xy, that whole thing cubed, the x gets cubed and the y gets cubed. All right? Same thing with a fraction. All right? Everything for number 8 gets the n exponent, the x and the y. Right? So if I have x over y cubed, it's x cubed over y cubed. Okay? Everything gets that exponent. And number 9 is a repeat for number 3. All right? It's just negative exponents you flip. Okay? So that was just a quick, brief review. If you need to rewind, okay, take that little bar, move that dot, slide it left to hear some of these things over. Go right ahead. We are about to move forward. All right, I think we've done this before, okay, for rational expressions, but I want to stress this one more time. Anytime you have an exponent that's a fraction, in this case, it's a to the p over r, it can be represented as the r root of a to the p, or the r root of a all to the p. I'll explain that in a minute. But the big thing to remember is top down. That's the top down. The bottom is out. So if I have a radical, here's my a. The top comes down and just stays here. Boom. The bottom is out. Top down, bottom out. Top down, bottom out. Boom. Top down, bottom out. It's a quick way to remember it. So, what is with this right here? I don't get this. What's the deal? It's just saying I can apply the P first. Okay, so let's say I have the square root of 2. I should do 8. Let's do 8. 2 cubed? No, 2 to the 4th power, because that's 16. That's an even square. 2 to the 4th power. Okay, I can do my 2 to the 4th power first and get the square root 2 to the 4th power is 16, and that would be 4. Or I can do the square root of 2 and put my power to the 4 afterward. It doesn't matter if I do this first or if I do this first. You will end up with the same thing. Okay, that's the square root, oh my God, of 2. I won't even do that out and confuse you guys. I should to prove you mathematically. Okay, if I have 4 of these things, square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. Okay, well, the square root of 2 times the square root of 2 is 2. Here it is. Square root of 2 times the square root of 2 is 2. 2 times 2 is 4. So it doesn't matter which one you do first. Honestly, I do whatever's easier first. This seems like it would be a lot harder to do. If I know that this is 16, I could take the square root of 16. It works out nice. I could do either one first. Do whichever one makes it easier first. And sometimes you just need to know your perfect squares and your perfect cubes to know which way would be easier. Okay, if you want to go ahead and do these out, go ahead. I'm about to do these right now, and I'm not going to go too slow or too fast, but again, this should be review. This first one, top left, I need to cube everything in here. I cube 2, 2 cubed is 8. Okay, when I have exponents raised to exponents, I multiply. It's A, 4 times 3, which is 12. C, 7 times 3 is 21. And there you go, it's done. Okay, let's look at top right. Okay, I've got to apply the 4th power to everything in here. Remember, this exponent to the x is a 1, just like this 5 has an exponent of 1. Okay, that's negative 5 to the power of 4, x the 1 times 4, and y to the 3 times 4. I didn't write it out this way to the first one because it should be review and it should be simple. Okay, x 4 times 1 is 4, y 3 times 4 is 12, and negative 5 to the 4th power is 25 times 25, 625. All right, let's do the next one on the left-hand side. All right, so I'm going to do this separately, and then I'm going to do this separately because it looks like I got to multiply them together, okay? So let's apply this 2 to everything in here. 4 squared is 16. P 2 times 2 is 4. Q 3 times 2 is 6. Times negative 3 cubed is negative 27. All right. P 5 times 3 is 15. And Q 2 times 3 is 6. All right. Now, just as a quick review, I multiply my big numbers together. So I have, all right, negative 27 times 16, and you guys have calculators. You can do this in the calculator. You get negative 432, all right? And what happens when I multiply common bases with my exponents? I add them. 4 plus 15 would give me 19. And Q is 6 plus 6, which would give me 12. There you go. All right, the next one, middle right. I can subtract these, but what I'm going to do is I'm just going to divide and reduce. To me, it's a lot easier 18 and 24. Do I have a common factor? I do. It's 6. 6 goes into 24 4 times. 6 goes into 18 3 times. Now I just reduce my variables. I have 1a on the bottom. I'm going to take 1a out of the top, so that becomes a to the 6th. b to the 10 cancels completely with b to the 10. Okay, now I have 2 c's on the top, and I'm going to take them out of the bottom 2, and that will leave me 3 c's in the bottom. So what do I have? I have 4 a to the 6th on the top. On the bottom, I have 3 c cubed. And there you go. Not too bad. All right, let's keep on trucking. Ooh, I got 4 more. 3 more. I'll be okay. Left one here. Our next example. We have 8x to the 12th, w to the 3rd. All right, and I have that to the 2/3. Again, top down, bottom out. All right, so I'm going to rewrite this in radical form. My top just slides down, so I have 8x12 w to the 3. This whole thing is squared. The bottom comes out. All right, so I'm going to apply my 2 first. I'm going to square everything first. All right, so that's the cubed root of 2 times 8 is 64. X to the 12, okay, 12 times 2, because it's 12 raised to 2, is 24. And w, 3 times 2 is 6. Now, I got to take the cubed root of each one of these individually. All right? I suppose I could have distributed that 2/3 as an exponent as well. But I'm trying to get this without any exponents or fractional exponents and, you know, the whole 9 yards. I'll show you that way next. That's probably an easier way. Okay? So what's the cubed root of 64? It's actually 4. The cubed root of 24 means that's x to the 24 divided by 3, right? And that would be 8. And then w, it's 6 divided by 3, which is 2. That's my answer. Now, let me show you another way, which is probably easier in this case. All right? I'm going to erase this right now, so if you want to write it, you can pause this. But let me show you a second way. And I'm going to leave this purple because that should be our answer. Okay? I'm going to go ahead and distribute this to all. So I've got 8 to the 2/3. I got x, 12 times 2/3. Okay? 12 times 2/3. 3 goes into 12 4 times. 4 times 2 is 8. There you go. W, 3 times 2/3. 3 times 2/3. My 3's cancel. W, 2. So all I've got to do is this. Top down, bottom out. I can do either one of those. I can square 8 and take the cubed root of 64, which is 4. Or I can take the cubed root of 8, which is 2, and then square it, which is also 4. Okay, so I could have done that either way. That second way seemed to be a little bit easier if you know what you're doing. But you still get the same answer. All right. Right one here, 16a cubed b to the 6, all raised to the 3/4. All right, this one is going to be not so nice and easy as far as our variables go. So let's just distribute this exponent right now. Okay, that's 16 to the 3/4. A, 3 times 3/4 is 9/4. B, okay, 6 times 3/4 is 18/4. Okay, now I can reduce that fraction for the B right now, but let's one thing at a time here. Top down, bottom out. Okay, that is the 4th root of 16 cubed. All right, this A is 9/4. B, this fraction reduces, has a common factor of 2, 9/2. I tell you what, because I am good with my exponents, I know that the fourth root of 16 is 2, and 2 cubed is 8. So when everything is all said and done, it's 8a to the 9/4, b to the 9/2. There you go. All right, this last one says compute. Compute. Let us do this. Bang. And this is where it pays. Oh, look at that. Amanda Robinson. Let's close that down right there. Bang. Done. Good. Now, let's compute this. And this is where it pays to know. All right. This is where it pays to know your, squares and cubes and all that jazz. So this is going to give me top down 16 cubed, bottom out. Okay. The square root of 16 is 4. That's easier to do. Cubed, 4 cubed is 64. Plus, anything to the power of 0 is 1. Minus 27, top down, bottom out. It's 27 squared, bottom out. It is a million times easier. The cubed root of 27 is 3. 3 squared is 9. So we have 64 plus 1, which is 65, minus 9. That would give us 56. I almost put 54 because I'm thinking factors of 9. But that is 56. Okay? So you see how it was easier. I mean, I could have cubed 16 and taken the square root of it and gotten 64. That would have been tough. I could have squared 27 and taken the cube root of that and gotten, 9. But it's a lot easier to work with smaller numbers. So, of course, I did the square root of 16 first to give me 4. I did the cube root of 27 to give me 3. Okay? And I could square 3, and I could cube 4, and it becomes a lot more manageable. Of course, you have a calculator, but this is the type of stuff that you shouldn't need a calculator for. If we're a test, I hope you put it in a calculator to check. But if it weren't a test, and this were in class, I hope you could do it without a calculator. I love this saying, so I kept it in the notes. And it says, let's take a look at negative exponents. We're going to work with them, exclusively now, the second half of the notes. That will be in almost every problem we do. So don't expect to see positive changes in your life if you surround yourself with negative people. LiveLifeHappy.com. That's such an easy thing to just read and believe. It's just so tough to practice. But if you do practice it, bam, fantastic. Okay? Simplify the following and express the final answer without using any negative exponents. All right? Let's start. Rules don't change. I still need to distribute this exponent to all the exponents on the inside. Remember that 4 has an exponent of 1. So it's 4, and I multiply. Negative 1 times 1 is negative 1. X, negative 2 times negative 1 is positive 2. Y, negative 1 times 3 is negative 3. Technically, that's over 1. Anything can be written as a fraction if I put it over 1. Now, what has a negative exponent? Those are the only things that are going to flip. Boom. Boom. So when everything's all said and done, I get x squared on the top, and I get 4 to the power of 1, which is 4, and y to the positive 3. Now, people say, well, what happens to this 1? It's multiplication. 1 times anything is itself, isn't it? And that's your answer. All righty then. Let's try the next one. Okay? Let's do top right. I'm dividing. Why don't I do this? Why don't I simplify my big numbers first, my coefficients? 7 goes into both 14 and 21. 7 goes into 14 twice, goes into negative 21, negative 3 times. I don't flip the negative 3. That is just a negative coefficient. It is not a negative variable. It is a negative big number. It is not a negative small number. Okay? So, what am I going to do? Before I cancel, let's flip everything that I need to flip. So I'm going to highlight everything that needs to flip. This negative 3 exponent should come down. Okay? This negative 1 exponent should pop up. And both these should flip. So I'm going to rewrite this. All right? I have 2. I have negative 3. My a to the 3 comes down. So I have a to the 5 times I have a to the 3. Okay. This b comes up. I already have a b to the 4 up. Now I have a b to the positive 1 up. Okay, that's multiplication. And both of these c's switch. So I've got c to the positive 6 up here, because that comes up. And I'm going to have c to the positive 8 below here. Let's clean this up. When I multiply two things in my numerator, two common bases that have exponents, I add the exponents. B to the 4 and b to the 1 give me b to the 5. Same thing in the bottom with my a's. I now have a to the 8. And what about my c's? Well, I'm going to reduce these. I'm going to take 6 c's out of the top and take 6 c's out of the bottom, and that becomes a 2. So when everything is all said and done, I have 2 b to the 5th in the numerator over negative 3 a to the 8 c squared. There you go. Let's keep on working. Keep on working. Keep on working. Boom. So next one, left. We have negative 2/3. I'm going to multiply negative 2/3 by every exponent that's in here. Remember, my 8 has an exponent of 1. I hate when that arrow just pops up right there. This really bothers me. And the little crosshair and the whole 9 yards. So let's distribute. Let's multiply 2/3 times all these. Okay? So I have negative 8 to the negative 2/3. W, negative 21 times negative 2/3 becomes positive 14. Okay? And Y, 24 times negative 2/3 becomes negative 16. All right? So technically, it's all over 1. The only things they're going to flip, this will flip, and this will flip because they have negative exponents. So I have W to the 14 on top. I have 8 to the 2/3 on the bottom. And I have Y to the positive 16. I know 8 to the 2/3 is top down, bottom out. Bottom out, top down. Okay, the cube root of 8 is 2. 2 squared is 4. So this is going to give me 4 for my 8 2/3. So I've got W to the 14 over 4y to the 16. That's my answer. So you can see with negative exponents, there's a lot more you get before you can start to do the right math. You've got to put the negative exponent, at least the way I do it. I mean, sometimes different situations arise where it's easier to take shortcuts, but you like to kind of see where everything falls before I reduce most of the time. Well, let's take a look at this next one. I am multiplying these all together. So let's do this. 4, there is nothing in front here but a 1. 4 times 1 is 4. F to the negative 2, okay, times negative f. A positive f times a negative f is negative f. Negative 2 plus 3 is a positive 1. Okay, times g to the 3rd and g to the negative 4th. That's g. If I add those, oh my goodness, look what I forgot to do. I'm so silly. This 3 needs to be distributed in first. PEMDAS. Okay, exponents come before multiplication. Before I can multiply both of those expressions together, I need to distribute that 3. I got so excited doing math. 4 after the negative 2 times g to the 3 times, okay, that's negative f. 3 times 3 is 9. G, negative 4 times 3 is negative 12. Now I can multiply these two together. My 4 gets multiplied times my imaginary 1 here. Well, it's a real 1. We just don't write it. 4. Okay, times positive f and negative f. Positive times negative is negative. F, and I add my exponents. Negative 2 and 9 give me positive 7. Last but not least, g times g. I add the exponents, 3 and negative 12, negative 9. Don't forget, it's all over 1. And the only thing that I'm flipping, the only thing with a negative exponent, The f does not have a negative exponent. That is a base that is negative, not an exponent. I don't want to flip that. So I have my g to the positive 9 in the bottom. Whenever I multiply a positive and negative, it should be negative 4f to the 7. That was a good problem. Really makes you think. Take your time. Okay, speaking about taking our time, we have about 9 more minutes to go. Let's keep this just a little bit over 30 minutes. Oh, my negative 3 gets applied to everything in the parenthesis. Okay, so let's go ahead and do that. Okay, everything. So I got negative 2 to the negative 3. I multiply them. Negative 4 times negative 3 is positive 12. V, 5 times negative 3 is negative 15. All over 3 to the negative 3, because everything gets the negative 3 exponent. 7 times negative 3 is negative 21. Okay. And V, negative 2 times, V, 2 times negative 3 is negative 6. All right. So everything's going to flip. This is the only thing with a positive exponent. That's the only thing that's going to stay. Everything else is going to flip. Okay. So up, down, 3 to the positive 3, negative 2 to the positive 3. Stays. Flips, okay? U to the positive 21. Flips, V to the positive 15. Flips, V to the positive 6. All right, well, let's do our math now. 3 cubed on top is 27. I have U to the 12th and U to the 21st. So since I'm multiplying those, I add those, and I get U to the 33rd. Okay. My V to the 6, I take 6 out here and 6 out here. I get V to the 9th on the bottom. And negative 2 cubed is negative 8. Look at us go. All right. Let's do something different with example, the next example. There's no number here. I'm going to reduce what I can first in my parentheses before I apply the negative 2. You can do that. Like in this exponent to the left, in this parenthesis to the left, I could have said, well, my V2 cancels with this, and I have 3 here. So 3 times negative 3 is negative 9. That will flip and become a positive 9 in the bottom. Like I could have simplified in the fraction first. That's what I'm going to do here next. Meaning, my big numbers, 5 goes into both of them. Goes into 15 3 times, goes into 25 5 times. X to the 0 is 1. Okay? This y to the 1, this negative 1, is going to come down and be a positive 1, and it's going to create, instead of 3 y's in the bottom, there will be 4 y's in the bottom. This z to the negative 2 will come up and become z to the positive 2. So now I'll have 2 z squareds in the top. Z2 and Z2 becomes Z4. So let me rewrite this. I have negative 3/5. I have x to the 5th on top and z to the 4th on top. In the bottom, I just have y to the 4th. Now, let's apply a negative 2 to all of these things. 3 to the negative 2. X to the negative 10, I'm multiplying. Z to the negative 8. All over 5 to the negative 2. Y to the negative 8. This is negative. I flip everything. Okay? I flip everything. 5 squared is 25. It's now on the top. Y to the 8 is on the top. 3 squared will be in the bottom, 9. X will turn to a positive 10 below. And z will turn to a positive 8 below. Don't forget the negative sign. If I square something, will a negative become positive is the million-dollar question. And it will. And it will. Don't forget, when we flip things, we still have to square them. We're squaring a negative number. Make that positive. Okay, a few more here. Oh my God, 4 more. Let's see if we can do this. These seem to be a little bit easier. Let's distribute a negative 2 to everything. 4 to the negative 2, p to the positive 6, r to the negative 10. The only things that flip are these. So I've got p to the 6th on top. 4 squared is 16, r to the 10th. Oh, after doing all that difficult work, it's nice to have an easy one. Okay, let's put a negative 4 to each one of these. Okay, so now I have negative 3 to the negative 4, x to the negative 28, and y to the positive 4. Okay, this is going to come down. 3 to the power of 4 is 81. Okay, yes, it's negative, but we are using an even exponent. So it's just like squaring a negative. It becomes positive, doesn't it? Okay, x to the negative 28 will come down and become x to the positive 28. And y will just stay up here to the 4th. Woo! Those are nice, easy ones to do. And last but not least, we have these two. Ooh, all right. Let's bring this whole thing down. Let's bring this whole thing up. Let's bring this thing down before we apply any of those exponents. So on the top, I've got 3x cubed to the positive 3. This is flipped. We've got negative 2x squared. I just flipped that. Y to the positive 5. Flipped it. Now it's so much easier to do. Okay, it's so much easier to do. Right? Let me re-explain that quickly with a highlighter. I flipped this up to get a positive 3. Okay? I flipped this down, yeah, to get a positive 2 exponent. And I flipped this down to get a positive 5 exponent. Now, why did I do that? Because it is so much easier, okay? It's so much easier to deal with these as positive exponents. And this negative exponent is connected to this whole thing. That's what the parentheses mean. So that whole thing needs to flip. All right, well, let's now do our math. I've got to cube the 3 and the x cubed. So I get 27x to the 9th over. Negative 2 squared is positive 4. X squared, y to the 5th. Last, but certainly not least, let's reduce where we can. 6 goes into 18 3 times, and 6 goes into 35 times. Okay, this negative 2 is going to come down here. So now let's wait. This c to the positive one is going to come up here, and both of these are going to flip. Okay, d to the 6 is going to come up, and then d to the 3 comes down. So let's simplify that. I got 3 in my 5. If I multiply these two together, I got a to the 7 now. I got 7 a's in the bottom. I got 9 c's on top. 3 of these d's will cancel with 3 of these. And just because I'm picky, nah. There you go. Godspeed, good luck. I will see you next time for Unit 4, Lesson 4. Sure, why not? See ya.